Good morning, grade fours. It is Thursday, which means it is our last natural science lesson for this week. And because tomorrow is a public holiday, so you have my permission to sleep late and to just chill out and relax. So today, as you can probably see, I am very cold my side here in Gauteng. I don't know where you are, but I hope that you are keeping warm and cozy. Winter is definitely well on its way. So stay warm, stay indoors, stay safe, and are you ready to learn? Okay, cool. So am I. Okay, so the joke for today is, why are frogs always so happy? Why? Because they eat whatever bugs them. Bug eat. Okay, you got it. Okay, grade fours, remember that if you've got any questions, please email them to grade4@WorksheetCloud.com. And let's kick this lesson off. Okay, so I thought we can just warm up our brains for today with a little bit of a starter activity. You are going to need a piece of paper and a pen or a pencil to do this activity. And you're going to, and I'll tell you when to press pause before I reveal the answers. Right, so what we have here, numbers 1 to 10, we have got words. And these words are actually names of animals. But the names of animals, the letters of the names have been all jumbled up to form a new word. So from 1 to 10, I want you, with your pencil and your pen and your piece of paper, I want you to try and reshuffle the letters of each of the words to create the name of an animal. Okay, so for number 1 to 10, all of them were names of animals. And so now is the time where I need you to press pause in the video, sit by yourself, maybe get your brother or your sister, your mom and dad, try and figure it out. What would an animal, if I have to rearrange these letters over here, what would this spell out for number 2, 3, and so on. So press pause, 3, 2, 1, go. Okay, right, are you ready to see the answer? Let's see. So, did you get horse for number 1, spider for number 2, cat for number 3, shark for number 4, goat for number 5, snail for number 6, tuna for number 7, deer for number 8, wasp for number 9, and predator for number 10. So I hope you enjoyed that. Just a little cute activity for us to just warm up our brains and to get us into the mode of science. I quite enjoy these activities just to sort of start the lesson off, and it's a nice way to just ease into the lesson instead of just jumping straight into it. And I think from now on, I'm going to do a lot more of these types of activities. Okay, so today, boys and girls, we are going to be focusing on input and output energy. Just to recap from yesterday's lesson, we spoke about different types of energy, from heat energy to light energy, to electrical energy, kinetic energy, potential energy, and so on. So we spoke about the different forms of energy. Now today we're going to speak about input and output energy. So now before I get into the input and output of energy, remember, and I did mention this yesterday, that the golden rule about energy is that energy cannot be created or destroyed. We can't create it and we can't destroy energy. It can only be transferred from one form to another. So energy is always transferred from one form to another. We can't create it, we can't destroy it, but it can change from one form to another form, from heat to light, from chemical to kinetic, from this to that. And so it is very, very important that for today's lesson that you continuously remember this statement, that energy cannot be created or destroyed. It can only be transferred from one form to another. So People, machines, and appliances, as you know, they all need energy input in order to work, to function, to switch on, to be alive, to work. Okay. They also have an energy output that may be useful. So in order for something to work, whether it is a machine, whether it is an appliance, or even us, we need energy. Appliances need energy. They need that energy to work and to function. And when they start to work and function, energy that is also then, it's converted, or should I say transferred into a different form. Right, so you can hear again, I hope you're all listening to me, and it is the sound energy that you can hear, and with me waving my hands around and talking as I teach, you can see I've got kinetic energy, and that is movement energy. Okay, so energy input into a device, into a person, into a machine. We then have energy output. So one type of energy that we put into something, we possibly sometimes can get a different type of energy out. Okay, and that is going to be the purpose of today's lesson. Right, so we are going to look at 3 different examples just so that I can explain the energy input and energy output concept a little bit easier. Okay, so the first example says, a boy is about to swim a race at a gala. So for those of you that love your swimming, which is like me, I was a big swimmer in school, so that's why I will always use swimming as an example. But so a boy's about to swim a race at a gala. He needs input energy to swim, and where does he get that input energy? He gets it by the chemical energy from foods that he eats. Any food that we eat, we then get chemical energy from the foods that we eat. When he swims, that chemical energy is transferred to kinetic energy. So that energy that he took into his body to allow him to be able to swim, and the moment that he starts swimming, it is then transferred into kinetic energy. Okay, here's just a picture. Chemical energy was our input into the boy that was about to swim, and as he's swimming, he's moving, and he's got this energy now to move and win the race, and it is then transferred into kinetic energy. Okay, let's look at our second example. Right, example number 2. A TV will only switch on if it is plugged in. When a TV is switched on, the electrical energy is transferred to light and sound energy. So remember that, and this comes back to a lot of the electrical appliances that we use today. So I've used an example of a TV. A TV, you know, will only switch on if it's plugged into the wall and electricity is running through it. So in order for a TV to work, the electrical energy is our input energy into the TV. And then what type of energy do we get out of it? Well, we get sound energy, so we can hear what is being said on the TV, as well as we get light energy. If you have to switch all the lights off in your room where there's a TV, your TV is still going to show that picture, and it is going to emit a light. And so our energy output is going to be light and sound energy. Okay, let's look at example number 3. Don't you love the animations? I must say, I do have fun making these presentations for you. So I really hope that you enjoy them. I like the bouncing letters. Okay, so example 3. Most torches need batteries in order to switch on and work. When a torch is switched on, the chemical input energy from the battery is converted into heat and light output energy. Okay, so all of you know that most torches need batteries in order to work, and in batteries are filled with chemicals that until a current is passed through that chemical, it's nothing is happening to that battery. So that chemical energy, the moment we switch that torch on, that chemical energy that's in the batteries, it's then converted into heat and light energy. Now I say heat specifically because a torch can get hot the moment, remember from yesterday when we spoke about thermal energy, that the moment that anything is above minus 273 degrees Celsius, it will emit heat energy. There is heat energy that is there. Okay, and you know torches that if you touch a torch, especially if it's been on for a very long time, you can feel it and it is a lot warmer. Right, so the chemical energy in this case is converted or transferred into light and heat energy. Our input energy is chemical energy and our output energy is light and heat energy. Okay, good. Right, now we're going to do a little activity, and again, while I do each one of these examples, if you want to pause the video, write down your own answer on your piece of paper, and then unpause when you've got your answer, then to then see my answer, and then you can see if you're correct. Okay, so what I've got here is something that we call a flow diagram. Now, a flow diagram is when we start at one point and we use arrows to represent the flow of something, a flow of information. So where have you seen these types of flow diagrams before? I hope you said that when I taught you all about food chains. Okay, so do you remember that with food chains, we had our different organisms that were separated by arrows, and the arrows in a food chain represented, yes, the flow of energy from one organism to another. Right, so here we've got a flow diagram, and the first box says energy in. So what type of energy is that? You can see it is blank. Then that gets transferred to the kettle, which is the device in question. And then your kettle, the energy out that is then released or emitted is then thermal energy. Okay, maybe if you've got a whistling kettle, you would have thermal energy and sound energy, for example. So it all depends on your type of kettle. So I want you to think, what would be your energy in into your kettle for your energy out to give you thermal energy? Yes, it is electrical energy. So we put electrical energy in to our kettle and we get thermal energy out. Let's look at our second example. So now here I've given you the device, which is a microphone. You need to determine and think about what would the energy in be and what would the energy out be. Right. So, okay, so that's it. We have energy in is electrical, okay? And then our energy out would be our sound energy. Good. So with our microphone, remember, and it all depends. Some microphones have got a cord, and there's a cord that is plugged in, and so it would need your electrical energy in. Some microphones do work on batteries, and that would be chemical energy in. It all depends on your type of microphone, but they all produce a sound, and that sound energy would be our energy out. Okay, example number 3. Right, so here we have a device which is a fan, okay, especially during summer. We definitely wouldn't be using fans now, but our device would be a fan. So what would our energy in be and what would our energy out be? Let's have a look. So we would have electrical energy in, that would go, electrical energy would be our energy in to our fan, our device, and what would we get out? We would get 2 types. So a fan does make a noise as the propeller or the propeller spins around. Or depending on your type of fan. So we do get kinetic energy, which is movement, and sometimes also fans do swivel and they move around. So we have kinetic energy and sound energy. Some fans, you can hear the fan working and moving. Remember that there can also be other forms of energy as well. It all depends from fan to fan. And our last example. So in our last example, what I've done for energy in is that I've given you the energy, which is light. And I've left the device blank and the energy out blank. So here you can be creative and decide on your own device. What device, so this requires a little bit of thinking. What do you think would require light in order to function or to switch on or to just work? And then what would the energy out be? So take a couple of seconds, think about it, and let's see what you come up with. So my answer could possibly be different to your answer, depending on what you said. So I said solar panels. So the light that comes onto solar panels that we usually have on our roof. And solar panels, what they do, they then give us electrical energy out. Okay, so that was just my example. I'm sure that you have come up with your own types of examples. Right, okay, so now what we are going to do is we are going to have fun. We're going to be doing a little bit of a fun activity. And let me get my activity ready for you. Okay, so we're going to be doing a fun activity together. And it's just to re-explain what our different forms of energy are. Okay, so let's have a look here. Make my screen big. Right. Okay, so as you can see, I've got some aliens, and I've got one alien ship, which is potential energy, and then in the other alien ship, I've got kinetic energy over here. I've got a whole bunch of aliens here that describe a lot of different things happening. So we're going to do one alien at a time, and I want you, as I'm picking that alien up, I'm going to then place it into the spaceship to see where it belongs, depending whether it represents kinetic energy or whether it represents potential energy. And let's see if you are right. So let's have some fun. Right, so if I have a ball that is falling, would that be kinetic or potential energy? Stored or movement? I think it is movement. Does it go in? Yes, it does. What about a charged battery? Kinetic or potential? Let's try kinetic. What happens? Oh, definitely not kinetic. So it has to be potential energy. Good. A river flowing. Flowing means it's moving. So immediately they would tell me kinetic energy. Yes, it does. A jet flying. Flying also means moving. Kinetic energy. Good. Unopened Coke. Let's see. Would it be kinetic energy? No, nope. It is potential energy. Okay, cool. Deer jumping. So what deer jumping is a moving action, right? Water behind a dam. Would it be potential or kinetic? Potential. Behind, it's referring to it not moving, but it's got the potential to move. Fireworks. I think of fireworks and I think of beautiful colors, but it's busy in the sky. So would it be kinetic? No, it wouldn't. Right. Fireworks. I think this is referring to before it goes off, it has the potential to do work and the potential to explode. And so there's fireworks. Plane landing. Would it be moving? Yes, it would. Stretched rubber band. Let's see. Potential? Yes, remember it's when you take a rubber band and you stretch it. An explosive, kinetic? No, hasn't gone off. When it goes off, it's a different type of energy. Before it goes off, it's got its stored energy. And lastly, a coiled spring. When you have a spring and we stretch it and we bring it together, would that be potential or kinetic? Potential, right, good job. Okay, so now we are going to have done a little game with potential and kinetic energy. Now we are going to do chemical and sound energy. Let me move my face a little bit down. Right. So here we've got chemical energy and we've got sound energy. This is a rock band that is playing. And let's see. Okay, so if we have an apple, would an apple be chemical or sound? Let me show you what would happen if I say sound. Oh my goodness, what happens? But if I say chemical, yes, please. And the audience goes wild. A bell ringing. Okay, bell ringing. Sound energy. Yes, it is. A car horn. Maybe some of you say it's chemical. No. Don't you just love the animations? A car horn would be sound energy. Good. Radio. Sound energy. A horn. Sound energy. A waterfall. Maybe some of you decided a waterfall. No. Waterfall is definitely sound energy. A balloon popping would be sound energy. A battery. Do you remember we've spoken about batteries? Chemical energy, good. Explosives, would it be sound energy or chemical energy? Let's see. Chemical energy, good. Wood, would it be sound or chemical? Chemical energy. And taco, which is a type of food. I love tacos. I like to have Taco Tuesdays. So tacos would be a form of food, and food would come in the form of chemical energy. Right. Good job. Okay, so that is a little fun activity just to talk about energy again and to re-explain. Let me just, move my camera a little bit up to my previous position. There it is. And that's just to recap our different forms of energy and just something fun to end off the lesson. So grade 4s, I hope that you've had fun today. I've had fun, and that is it for our week. And you have got an awesome long weekend ahead of you. Remember, stay safe, be happy, smile. I hope you share all of my amazing, incredible jokes with all your friends and family, and just have an incredible day. From me, Miss Kun, Hakuna Matata. Be kind to one another, grade 4s. Bye.